Hello, my name is Gabriel Garfias, and today I'll be talking about a biohybrid consisting of nanowires and bacteria. So scientists at UC Berkeley have created a biohybrid that takes in carbon dioxide, sunlight, and water and creates acetate, which is composed of acetic acid, which is actually found in vinegar. Now you may be asking what a biohybrid is, so let me tell you. A biohybrid is a system consisting of biological and non-biological components. So in this instance, the silicon nanowires are the non-biological components, and the bacteria are the biological ones. So as you can see, this biohybrid consists of two chambers. So the chamber on your left houses the silicon nanowires, the bacteria, the carbon dioxide, the water, and the acetate which is produced. And the chamber on the right houses the oxygen, which is another byproduct of this process. So in the real world, the nanowires are going to act as solar cells or solar panels, meaning they'll absorb photons, but they'll also act as semiconductors. Once a photon is absorbed, the nanowires will generate electrons, which will then transfer over to the bacteria. Now the bacteria will then take two carbon dioxide molecules from the atmosphere and convert them into acetate and oxygen. So a little background information about silicon nanowires. So many of us know about bacteria in general, but what about silicon nanowires? Well, discovered in 1997, silicon nanowires are a way engineers hope to further minimize the size of transistors. The reason why lies in the size of silicon nanowires. One nanowire is between 30 to 60 nanometers wide. To put that into context, imagine you had a single hair, which is between 60 to 120 micrometers thick. You would have to cut that piece of hair 60,000 times to get to the thickness of one nanowire. You may ask, why silicon then? Well, silicon can be a semiconductor and an insulator depending on the conditions. Plus, it's very abundant on Earth. In other words, you have a cost-effective material that is versatile when it comes to its electroconductive properties. So why is this important? As I mentioned before, this process takes in carbon dioxide, which is a plus for Earth's atmosphere, but its true potential lies beyond Earth. By having a system that reproduces and takes in useless compounds and spits out useful ones, a ship's payload weight is reduced, which reduces space travel costs for NASA, and also makes room for other cargo. Furthermore, once set up on Mars, this biohybrid will be able to reduce the amount of carbon dioxide in the artificial atmosphere of the astronauts' living arrangements. Not only that, but the material created from this process may help astronauts develop an assortment of compounds ranging from fuels to drugs. Lastly, you may ask, why not just, ship plants to Earth, or plants to Mars, sorry. The reason behind that is because this biohybrid is actually 10 times more efficient it's 10 times more efficient than typical plants when it comes to solar conversion efficiency. Now, after reading about this, I was quite impressed. The articles were well written, informative, and consistent with each other. But I still have a few questions. For example, the articles referred to the conversion process as similar to photosynthesis, but what's the actual name of it? Is it carbon fixation, or is it something else? How exactly are the bacteria doing this? One of the articles also mentioned injecting quantum dots into the bacteria. I'd like to know more about creating those quantum dots, the process that went into creating those quantum dots, and how exactly they were injected. I'd also like to know about the potential organic compounds that can come from this, because one of the articles mentioned that we'd be able to create sugars and carbohydrates from this process. Is it just as simple as swapping the species of bacteria, or is it something else? I'd also like to know more about the process that will go into getting the water required to undergo this process, because as we all know, Mars isn't known for its liquid as Earth is for water, really. However, the articles did mention that we would basically have to drill into polar ice caps, or at least into the water that is understood to be below Mars's surface. So, anyways, it was fun to read about, and I can't wait to see what becomes of this. Thank you.